Hey guys, back for another radio video here for all you transistor and old vintage radio collectors out there. Got a couple of late 50s General Electric AM transistor radios. You guys remember this one's been in a couple of other videos. I was going to check it out. I actually looked at this one prior to doing the video, and I'll tell you what, this thing needs a lot of work. It's missing parts. This is the one I use a lot. I use this one almost every day. This is one that I picked up at an antique store. Really cheap, and as you can see, it works really well here.
And you twist it off.
But I don't want to play it too loud, too much, because copyright. We don't want any copyright problems. But I'm going to show you really briefly how I had to modify some of these radios, because a lot of these older radios use batteries that they no longer make, or you can maybe get them, and they might be real expensive. So, and this is a very old battery here. I ought to be like everybody else, and oh my God, this is an old battery. I can throw this on eBay and get $1,000 for it, and maybe $500 shipping. No, I'm not going to do that. Let's go to this radio here. I'll show you. Well, real quick, let me go back to this one. I've already got the screws loose because one-handed videos here. I'll show you how I did this. You can do it one of two ways. What I did is I did this. I got another battery pack, which is for 6 AA batteries, because this radio operates off of 9 volts, because the old battery would have been this style here, 9-volt battery. And I added the newer style 9-volt snap. Now, yes, I could use a regular 9-volt battery like this. It'd work perfectly, not a problem. But the reason I did the 6 AA's is because if you think about this, and you got to think about this on a little bit of a scientific level, this is like a 5-gallon bucket of water versus a 1-gallon bucket of water. It's still water. You know, pretty much, it's still power, energy. Which one's going to last longer? Right, the big one. You got more to use. There's less to use in this one. So running this radio a couple hours a day, every day, I got about a week out of a battery. And that was even with a heavy-duty battery. With something like this battery is pretty much what you see here, 6 individual cells, which 1.5 volt times 6 is your 9 volts. So it's going to last a much longer time. So yeah, that would be this one here that I use every day. Quite a bit of very, very well-performing radio. So I'm just going to stick the back on that, set that aside. That one works. This one does not. And here's why. Let me show you what the battery connection looked like. Let's see. Oh, wow. Screws out, and it doesn't even want to pop open. There we go. All right. Let's see what this is. Yeah, there's your model number and everything right there on the radio. Made in the United States. This one, I didn't even take it apart. It's missing all the screws even. This is the original battery snap. There's people on eBay and stuff that makes adapters that you can snap onto this to convert it from that battery to a newer 9-volt battery. So, but you know what I did? You saw what I did. I just ran a new wire with the new connection and saved the snap. But here's where the circuit board looks like here. Let's see if we get it down here again, one-handed videos. This one is missing a lot of parts, guys. Turn this light back on here so we can get a, see if that'll, well, that light doesn't want to turn on. So I guess, there we go. Anyway, right off the bat, see that capacitor is, the end's gone off of it. And there should be another disc capacitor next to that capacitor. That's like an 047. The disc would have been an 01. There's a capacitor that should have been here that was missing. Should have been about a 65 microfarad. There's a small one here, probably the bypass cap. There should have been like a 6 to an 8 UF capacitor microfarad there. There should have been like an 8 to a 10 here on the ratio detector from the volume control. That's gone. There's another one that should have been here, which would be your coupling capacitor, probably a 10 microfarad. I'll have to look at my schematic. That's missing. And then over here, there should have been like a 0.1 cap that would look similar to that, and that's missing. So I don't know why, or somebody was trying to recap, get the radio to work, but when I opened up the radio, there was these old capacitors laying loose inside the thing. So there's the other one. So I don't know what was happening there, except there's a new one here laying there, but that's a 15. So yeah, I'm going to have to do a lot of work on this one, but I thought we'd give it a quick check out. What I mean by a schematic, guys, a schematic, I'm not going to get into all that stuff on my videos. I want to keep them kind of more of a show and tell short video, because there's plenty of other good people on YouTube that can get into the scopes and schematics, so there's no need for me to make a video like that. Schematic is like pretty much your information on your radio. This book's probably not got this radio. I'll have to pull another one. Schematic just tells you your voltages, circuit boards, what parts go where, value of the parts and where they go, and what voltages you should have on, you know, where. So if you're going to work on one of these, you definitely need schematics if you don't know, not that familiar with them. And if you don't have any schematics paper-wise, you can actually, I think you can look some of them up online. There's other places. They're called Sam's Photo Facts. So yeah. So anyway, I don't want to get into too much of that. There's other good videos on there. Mine's just kind of a show and tell you guys what I did and what I found. I'll do more videos later. Maybe I'll do some another video on this once I get all the proper parts in it, and we'll try it out. So again, yeah, thanks for watching, guys, and stay tuned for other videos.